Okay, Geometry, Chapter 6, Section 2. This is bisectors of triangles. So we're looking at different bisectors that might intersect and form certain things. The first one we're going to look at is what's called the circumcenter. And the circumcenter, I'll go ahead and write this and then give an example. Okay, the circumcenter is where all three perpendicular, upside down T is perpendicular, just to save a little bit of time, all three perpendicular bisectors intersect. I could probably throw in the word where at the beginning of that statement, where all three perpendicular bisectors intersect. So if I had a triangle, let me just pick something like this. And again, the book will have them drawn perfectly for you. I'm going to draw, let's see, I'm going to draw them. Had to take a little pause there and see which way I wanted to draw this. I want to draw these in a dash line. And so I would take this, any of them, it doesn't matter. Let's create, I want to make a little reference point for myself. Let's create an approximate midpoint. Again, these will be given to you in the book. I'm approximating these just by visual. And what I want to do is I want to create a perpendicular bisector. And I'm going to get these as close as I can. So let's label this as a BC. The label is not important once we learn how to do it, but it is pretty important as we go through here. So I've created a perpendicular bisector of side AB. So now I'm going to go to side AC, and I'm going to create a perpendicular bisector. Whoop. Actually, I would like to do that with the dashed line as well. And I'm going to call that, give some lines here. I'm going to call that a right angle. Again, a little bit of human error. And then my next one, you can see, is not going to be the best. So I'm going to modify just a little bit. And I'm going to do this and so that point right there would be called the circumcenter. Okay. Now, what is the circumcenter? Well, if I drew the distance, and this is going to be just freehand, if I took the distance from A to the circumcenter, the distance from C to the circumcenter, and the distance from B to the circumcenter, all of those distances would be congruent. Again, I apologize for not using the straight. I needed the colored line just to show a little contrast to that. So the circumcenter is equidistant from all three vertices. So let me write that. The circumcenter is equidistant from all three vertices. Okay, so perpendicular bisector of all three sides. Find the intersection point, and that intersection point is what's known as the circumcenter, which is equidistant from all three vertices. I know I sound like I'm repeating myself, and I guess I am. So the next one we're going to do is called the incenter. And so I'll bring up another triangle. Let's do this one this time. And we're going to find the incenter. Okay, I'm going to move this over a little bit. Okay, what we're going to be doing now, instead of bisecting the sides, is we're going to bisect the angles. So there's A, there's B, there's C. Again, just a little bit of, get rid of that little dot that just appeared there. There's going to be a little bit of human error. We're going to do the best we can. So we're going to bisect angle B. So cutting that angle into two equal pieces. We're going to bisect angle A. I guess I could have done that in order, ABC. So we're going to go right about there. And then you can probably see what's happening here. We're going to bisect that angle. And what we have just located is right there. And that is the incenter. And so we remember on our circumcenter that our circumcenter is equidistant from all three of the vertices. Our incenter is equidistant from all three sides. Okay, so again, if I were to, let's go with a different color. Let's go with red this time. If I were going to find the distance from my incenter to AC, I would need to, I want to get rid of this because I'm going to draw in that space. I would need to make a 90-degree angle because distance is perpendicular. So that distance, this distance, and this distance would all be congruent. So my distance from the incenter to AB, to AC, and to BC would all be congruent. And they will set up some equations, or set up some triangles, and just ask you for some missing pieces. So that's how we're going to use that. We're going to use that a little bit. So that takes care of the circumcenter and the incenter, where we look at bisecting the sides perpendicularly and also bisecting the angles.